Sup guys, welcome to my channel. Today we're going to be solving a programming interview question called climbing stairs. This is an easy question and it uses dynamic programming to solve the problem. So the problem description is, you are climbing a staircase. It takes n steps to reach to the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Note, given n will be a positive integer. So here we have two examples. In the first example, the input is 2, which means that we have to climb 2 steps to get to the top. The output would be 2 because there are 2 ways to climb to that 2 steps on the top. The first step is to climb 1 step at a time, and the second step is to climb 2 steps at once. And in the second example, the input is 3, so in 3 steps we get to the top, and the output is also 3 because there are 3 ways to climb to that top of the stair. The first way is to climb 1 step at a time, 3 times. The second way is to climb 1 step and then 2 steps, and the third way is to climb 2 steps and 1 step. Okay, so now let's analyze the question and see how we can solve the climbing stairs problem. Here we have the maximum amount of steps that the staircase has, which is going to be our input, and here we have the amount of ways to reach that top of the stair, which is our output. So we know that if there is only 1 step to the top of the staircase, there is only 1 way to get to the top of the staircase, which is to take 1 step. Remember, we can take either 1 step or 2 steps at one time. So in the previous examples, we saw that to get to the top of the stairs that has 2 steps, and there are 2 ways to do it, and to get to the top of the stairs that has 3 steps, there are 3 ways to do it. There are 5 ways to get to the top of the steps with a maximum of 4 steps in the stairs, and that is to take 1 step at a time for 4 times, or to take 2 steps at a time, then 1 step at a time, then another step. Or we could take 1 step, 2 step, 1 step. We could take 1 step, 1 step, 2 step, or we can take 2 steps and 2 steps. And that would all lead us to the top of 4 steps. And now we can see that there is a pattern here, and the pattern is that the amount of ways to get to the top of the stairs is the amount of ways to get to the top of the previous 2 steps. For example, if we are calculating the amount of ways to get to the top of the steps with the maximum steps of 4, we have to calculate the amount of ways to get to the top of the steps with a maximum of 3, and the amount of ways to get to the top of the steps with a maximum of 2. So here we can see that the maximum amount of ways to get to the number of steps with a maximum of 4 steps is 3 plus 2. And then here we can see that the number of ways to get to the top of 5 steps is 5 and 3, which is the previous 2 ways to get to the maximum steps. So this is also known as the Fibonacci sequence, where each number is equal to the sum of the previous 2 numbers. We're going to implement the Fibonacci sequence using dynamic programming, where we have temporary variables storing the previous Fibonacci sequences, so that once we have the Fibonacci sequences calculated for each number, we don't have to calculate it again. Now let's try and write this code out in Python. First, let's handle our corner cases, which is when the maximum amount of steps in our staircase is 1 or less than 1, because we know that if the maximum amount of staircase is 1 or less than 1, there is only 1 way to solve this problem, which is to take 1 step. So if n is less than or equal to 1, we'll return 1. Now let's set some temporary variables to store the previous 2 numbers. So the first is going to be 1 for now, and second is going to be 2 for now. The second is going to store the results once we loop through all of the numbers in n. So since we already have 1 and 2, we're going to start from 3. So for I in range of 3 to n plus 1, we want to make sure that we get all of the numbers up to n. And we're going to store a temp variable that will have the sum of the first 2 numbers, and then we'll set the first to second, and our second is going to be the temp. So we're going to keep doing that, and we're basically adding the two previous numbers, and then we're pointing the two previous numbers to the next previous numbers. And then we can return that result. So we'll return the second, and let's run the code. And now we can see that we got the right answer. Let's try to use another example. We'll try 4. And we can see that the amount of ways there are to reach the top of a staircase with 4 steps is 5, because we added the previous 2 ways, which is 2 and 3, so we get 5. And that is the way we solve our problem. So we added the previous 2 numbers until we got to n, and that gave us our result. We solved the climbing stairs problem with the Fibonacci sequence in linear time and constant space, because we had to loop through all of the items, and then we did not use any extra data structure to store the items, so we used a constant space. If you guys like this video, please give it a thumbs up, or if you have any questions, please comment down below. Please don't forget to subscribe. Thank you guys so much for watching, and see you guys in the next tutorial. Bye.